In this video, you'll learn how to find the coordinates of one of the endpoints of a given segment or line, given its midpoint. And you will also learn how to find the coordinates of a point on a segment or a line, given the ratio of its distance of that given point to the endpoints. If M is the midpoint of segment xy, find the coordinates of x if point M is -3, -1, and y is -8, 6. So let's draw that segment first, segment xy. So we can analyze this clearly, and so we'll be able to solve the problem. So it says here we have segment xy. So the endpoints are x and y. And then M is the midpoint. Should be somewhere in the middle. So this is M. And we're given that the coordinates of M is -3, -1. And then y is -8, 6. So now we need to find the coordinates of point x. Right, now to solve this, we need to use the midpoint formula. So the midpoint formula is just the average of the x coordinates and the y coordinates. But we're given here the midpoint, which is -3, -1. So this is just -3, -1. So this is the x coordinate of the midpoint and the y coordinate. So this one corresponds to the average of the x coordinates, and y corresponds to the y coordinate. So we can just equate them. So this is x sub 1 plus x sub 2 over 2 equals -3. And then the other one is y sub 1 plus y sub 2 over 2 equals -1. Then we plug in the given values. So we only have, let's say this one is x sub 2, y sub 2. And then point x is x sub 1, y sub 1, which is the unknown. So we can solve for x sub 1 and y sub 1 using these two expressions here. So x sub 1 plus x sub 2, -8 over 2 equals -3. And the other one is y sub 1 plus y sub 2, which is 6 divided by 2 equals -1. And now we can calculate for the value of x sub 1. We can multiply both sides by 2. Then this one would give us, let me delete this first. I should have written this. Let's solve for x sub 1 first. So x sub 1 is x sub 1 plus -8 is just x sub 1 minus 8 equals -3 times 2 is -6. Then we add 8 to both sides. Okay, this cancels out. Therefore, x sub 1 is equal to +2. Now we already have the value of x sub 1. Then we can solve for the y coordinate, or y sub 1. So x sub 1 is equal to 2. And we solve for the y coordinate. It'll be y sub 1 plus y sub 2 over 2 equals -1. Then we can multiply both sides by 2. Then we have y sub 1 we plug in the value of y sub 2 plus 6 equals negative 1 times 2 is negative 2. And then we can solve for y sub 1 here. We subtract 6 from both sides. Therefore, y sub 1 is equal to negative 8. Therefore, the coordinates of point x is just 2, negative 8. Now let's solve another problem. If R is the midpoint of segment QS and QR is equal to 8x minus 51 and RS is equal to 3x minus 6, we find QS. So let's draw that segment first. QS. Okay. So let's say this is segment QS with endpoints Q. This is the first endpoint Q, and then the other one S. And it says that R is the midpoint. So R is somewhere here in the middle that divides segment QS. And it says QR. Okay, the distance from Q to R just denotes as this is 8x minus 51. So that one. And the distance from R to S is 3x minus 6. Then we find the distance of QS. So it's given here in the problem that R is the midpoint of segment QS. So that means QR here is just equal to RS. So we can just equate the values of QR and RS. So that would be 8x minus 51 equals 3x minus 6. Then we solve for the value of x. So this is 8x. Okay. We just add 51 first. Then we have 8x equals 3x minus 6 plus 51. So that is 45. And then we subtract 3x from both sides to get rid of 3x on the right. Then we have 8x minus 3x, that would be 5x equals 45. Then we divide both sides by 5. Then x is equal to 9. Now we already have the value of x, so we can solve for QR and RS. But QR and RS are just equal. Then we can solve either of them. So QR is equal to 8x minus 51. Then we plug in the value of x. So this is 8 times 9 minus 51 equals 72 minus 51. Therefore, QR is equal to 21. And since QS, let me delete this. Okay. Since QS is equal to QR plus RS, and QR is just equal to RS, so this is just 21. Okay, they're both equal to 21. So this is just 21 plus 21. Therefore, QS is equal to 42. Now let's solve another problem. Given the points C, -1, -5, and D, -7, 11, find the coordinates of point E on CD such that the ratio of CE to ED is 5:3. So let's draw a segment CD first. So this is point C and this is point D. And it says that point E is somewhere on segment CD And the ratio from CE to ED is 5:3. So it could be here or it could be here, somewhere here. So let's just put point E anywhere. So we're given the ratio 5:3. All right. Point E here is not the midpoint of segment CD, but it is on, the point is on segment CD. So this is a problem on section formula. So we can use the section formula on this. So if point P, let's say point P x sub y divides the line or segment joining, let's say A x sub 1 y sub 1 and B x sub 2 y sub 2 in the ratio m:n, then point P is just equal to m x sub 2 plus n x sub 1 over m plus n, then m y sub 2 plus n y sub 1 over n m plus n. So in this case, our m here is 5 and our n is 3, right? And then we're given, what is given here, point C, -1, -5, and point D, -7, 11. So we can assign point C as x sub 1 y sub 1 and point D as x sub 2 y sub 2, and then we plug into the given formula. All right. So let me delete this first. All right, our point here is E, point E. So that is xy. So this is just m x sub 2 and x sub 1 m plus n, and then m y sub 2 plus n x sub 1 over m plus n. Then we just plug in all the values. So m is 5, so that is 5 times x sub 2, which is -7, plus n, which is 3, times x sub 1, which is -1, over m plus n. And then m 5 times y sub 2 is 11, plus n 3 times, this is y sub 1, not x sub 1, y sub 1, which is -5, over m plus n. Now, m plus n is 5 plus 3. So these values corresponds to the coordinates of point E. So the x-coordinate of point E corresponds to this, and then the y-coordinate to this. Then we can now solve for the coordinates. Okay, we can do this separately. So the x-coordinate of point E is equal to 5 times -7 plus 3 times -1 over 5 plus 3. So this is -35 minus 3 over 8, which is -38 over 8. They're both divisible by 2, so we can reduce this fraction as -19 over 4. And then for the y-coordinate of point E, this is 5 times 11 plus 3 times -5 over 5 plus 3. So this is 55 minus 15 over 8. So this is 40 over 8, which is just equal to 5. Therefore, point E has x and y coordinates negative 19 over 4, 5. So this is the final answer. You can always check this by plotting this on a coordinate plane and then check if the ratio is really 5:3. The ratio of the distance. Now let's solve another one. Given the points R, 6, -2, and T, -9, -7, find the coordinates of point S on RT such that the ratio of RS to ST is 3:2. So this problem is just similar to the previous problem. So we're given here segment RT. Let's say this is point R and this is point T. And the coordinate, no, point S is on segment RT with the ratio 3:2. So we don't know. Point S could be here or point S could be here. Right? It says the other side is longer than the other one. The distance from end point R or point R to point S is, and point S to point T is 3:2. So let's say point S is here. And we're given the coordinates of point R, which is 6, -2, and then point 2, which is -9, -7. So in this case, we will use section formula again. And we're also given here the ratio m is to n, which is 3:2. Right? So m is to n is just the ratio of RS to ST. Right? So let's solve this using the section formula. So S xy is equal to m x sub 2 plus n x sub 1 over m plus n. Then m y sub 2 plus n y sub 1 over m plus n. Then the x coordinate of S corresponds to this, and then the y coordinate to this one. So we can solve this separately. So the x coordinate of point S is just equal to m x sub 2. So m is 3 times x sub 2. Right, so let us assign first for our x and x sub 1, x sub 2, and as well as y. So let's say this is x sub 1, this is y sub 1, and this x sub 2, this is y sub 2. Then x sub 2 is -9 plus n, which is 2, times x sub 1, which is 6, over m plus n, 3 plus 2. So this is just -27 plus 12 over 5. -27 plus 12 is -15 over 5, and that is equal to -3. So now we have the x coordinate of point S, which is equal to -3. And now we can solve for the y coordinate of point S. So the y coordinate of point S is just equal to m, which is 3, times y sub 2, which is -7, plus n, which is 2, times y sub 1, which is -2, over m plus n. So this is -21 minus 4 over 5. So this is -25 over 5, which is just equal to -5. Therefore, the y coordinate of point S is equal to -5. Therefore, point S on segment RT has the coordinates -3, 5. So this is our final answer. Now let's solve another problem. Given the points J, 4, -7 and L, -2, 13, find the coordinates of point K on JL such that the ratio of JK to JL is 1:4. So this is just similar to the previous two problems. So we're given here segment JL. So let's say this is point J, which has the coordinates 4, -7, and then this is point L, which has the coordinates -2, 13. And it says that point K is on segment JL and the ratio of JK to JL is 1:4. So that means point K could be somewhere here or somewhere here. So let's just say point K is here. Okay, with coordinates x, y. And we're given here the ratio m is to n, which is 1:4. So this is from the ratio of JK is to JL. Then we can use the section formula again for this. So point K with coordinates x, y is equal to m x sub 2 plus n x sub 1 over m plus n, and m y sub 2 plus n y sub 1 over m plus n. So this one, the x coordinate corresponds to this, and the y coordinate to that one. Alright, so let's solve for the coordinates of point K separately. So the x coordinate of point K is just equal to m x sub 2 plus n x sub 1 over m plus n. Then we plug in all the values. M is 1 times, okay, so let's assign this. This is x sub 1, y sub 1, x sub 2, y sub 2. So 1 times x sub 2, which is -2, plus n, which is 4, times x sub 1, which is 4, then 1 plus 4. So this is -2 plus 8 over 5. So this is 6 over 5. Alright, take note here. This problem is similar to the previous two problems, except that, okay, I forgot to note that this ratio 1:4 is from JK, from here, from this one, to JL, the whole segment. So that means K here, point K is 1/4 of the way from J to L. Therefore, the ratio of JK is to KL. Let me change this, because I forgot to note that it's not, the given ratio here is not JK is to KL. It's JK is to JL. So the given ratio is for JK and JL, which is 1/4. So that means point K is 1/4 of the way from J to L. Therefore, the ratio of JK to KL is just 1:3. And now we can apply the section formula. So let's plug in everything. So our m here is 5, 1, and our n is 3. And then we plug in everything. So m is 1 times x sub 2, -2, plus n, which is 3, times x sub 1, which is 4, over 1 plus 3. So this is negative 2 plus 12 over 4. So this is 10 over 4, which is just 5 over 2. So the x coordinate of point K is equal to 5 halves. And now we can solve for the y coordinate of point K. So y the coordinate of point K is just equal to m y sub 2 plus n y sub 1 over m plus n. So m is 1 times y sub 2, which is 13, plus n, which is 3, times y sub 1, which is negative 7, over 1 plus 3. So this 13 minus 21 over 4. And this is just negative 8 over 4. And this is equal to negative 2. Therefore, the coordinate of the value of y of point K, y coordinate is equal to negative 2. Therefore, the coordinates of point K are 5 halves and negative 2. So this is our final answer.